Hello all. Uh, the topic that we're discussing today is something called Decepticon. I've actually borrowed this term from the famous Transformer movie. The reason is simple, like I just am trying to build some more intelligent uh, monitoring utility for wireless networks. The networks which specifically are complying to IEEE 2.11 standards. So, yeah, before we go further, should our demos work properly, I would recommend or request you all guys to just shut off all your wireless network interfaces so that our demo will run smooth as well. I would not actually in comply with any of laws here. So actually, this whole concept of Decepticon started by the time we've been flying back to India after BruCON, and on the airport itself, we've been trying to answer certain questions like, okay, uh, there is able twin. We've been researching about, or rather, we are trying to learn about wireless networks for more than like 6 years now. Uh, the first talk that we presented in 2014 was eventually on to Ableton itself. So that talk, then we thought, okay, now it's time that we should actually use the legacy Ableton to do something more juicy or to make it work on some different level. And that is how this whole brainstorming started. It was me and Amrita who've been discussing this for like 2 months, right from the day we've started from here. And then Krish joined us, and yeah, he brings in a lot of system level programming experience, so that actually helped us building Decepticon in a little different way than ever. So yes, some boring slides you may feel, but yep, there's always been a dilemma like should we use Wi-Fi or not? With Wi-Fi, we have a lot of good things like ubiquity. We have got a lot of ease of access, no mesh of wires and things like that, no maintenance required and things. Uh, Coming in, I mean, considering IoT and things like that and picture, yep, there are many more applications which we can actually draft here, but that's not the scope of our talk here. All in all, Wi-Fi makes a lot of life easy here, isn't it? But the other way around is like that's big hole in security we just cannot ignore. Uh, Prone to dozens of attack varieties specifically because, yeah, I mean, there are MITM, DOS, and whatnot. There are n number of attacks, right? And well, now here comes the fact, like many of you may be managing your security team or maybe managing the security for a certain organization, and this would obviously be a question from the stakeholders, like, do we really need to put security at a paranoid level in our organization, or should that be something manageable otherwise? So yeah, that's kind of a trade-off, I would say. Some statistics, some very cheap statistics for that matter. If you see like how many open wireless networks we actually come across in publicly dense area, it's pretty huge number, more than 50%. And WEP, considering the statistics in India, they are pretty high numbers still. I won't talk about WPA and WPA2. Yeah, my apologies for the typo there. You might find some more. So some beautiful usages of Wi-Fi, I would say through attacker's perspective. So timing-based attack, side channel attacks, replay attacks, privacy cracking attacks, and the prime one, Able Twin. So before we go further, for those who are not much aware, like what exactly is Able Twin and things like that, so if we're going for the theory, I would prefer you guys watching a demo. I hope it's visible. So we have trained our wireless network interface card into monitor mode using AirMon NG. So I use a tool called MDK3, Murder That Kill, 3rd edition. So it's basically started sending a lot of beacon frames. We'll soon come to know exactly what exactly beacon frame is. So you can see some certain garbage SSIDs being thrown there. All right. So now theoretically, what exactly Evil Twin is? Evil Twin is nothing but a fake access point, which will cater to the need of user in a way to make user feel, okay, he is actually experiencing an uninterrupted network connectivity wherein the administrator or the inceptor behind Evil Twin will try to harvest a lot of data from this whole connectivity goof. So some small animation. So this is legitimate network scenario. Perfect. So for user, there won't be any network connectivity issue experience. But for a rogue access point administrator, it would be mine of data. So some terms, yeah, for those who are not much aware of wireless networks, access point is basically a little intelligent device which is capable of kind of routing data, kind of issuing wireless network connectivity to hosts. So here it is. This is nothing but your access point. SSID. SSID stands for Service State Identifier, usually a name assigned to a specific wireless network. So here SSID I've crafted as menu. And user is nothing but the station or host or node according to IEEE 802.11 glossary. So by book, a phishing Wi-Fi access point that looks like a legitimate one with the same SSID typically occurred near free hotspots, usually found near free hotspots such as airports, cafes, hotels, and libraries. Hard to trace since they can be launched and shut off suddenly or randomly and last only for a short time after achieving their goal. So I won't be actually attributing threat actor here so that we can get, our motive of talk is not basically to learn about motive of this particular attacker. Let's go ahead. So some frames, probe request and response, beacon frames, and combination of beacons and probes. So what basically probe request or response is like? I'll tell you something very basic. So every time we enable wireless network interface card on our phone or any wireless network interface enabled device, what exactly it does, it have a particular memory, we call it cache, which holds a lot of names of the SSIDs to which that device was connected in past. Now the thing is, when the interface is enabled, the inherent behavior of that wireless network interface card is it will start trying to check whether there is any device which is present to which it was connected in past. So how does that thing happen? It basically crafts a specific data link layer frame, we call it as a probe request, where the SSID of the previously connected network would be embedded. So that is as a probe request. Same thing, reverse is probe response. So now probe responses are usually generated from access points where they reply back to such probe request saying, yes, I'm available here, and yes, this is the connectivity. Having said that, the next thing, which actually should have been previous, that is beacon frames, is a beacon frame is nothing but an advertisement frame which actually advertises a specific access point's presence and identity in the local radio periphery. And combination of probes and beacons, yes, that is how you basically try to understand wireless network in a little more depth through an attacker's perspective. Some of the modes that we usually run our wireless hardware is managed, ad hoc, master, and monitor. In case of managed mode, it is nothing but a station mode, nothing but a mode of a particular device which is there on our phone, maybe on our laptop or something. Not much intelligent in that context, I would say. The other is ad hoc. Ad hoc mode is where you actually try to patch up certain things in protocol stack and try to make things work according to you, but they may not always be 100% compliant to IEEE 822.11 standards. The third is master mode. Usually this is a mode we have observed, we observe in case of access points or those network intelligence devices which can speak on wireless networks or other wireless channel. Monitor mode, this is something which is similar to our promiscuous mode in case of IEEE 802.3 networks. This actually allows you monitoring a lot of activity on the local radio periphery. Scanning and stumbling, something that we should know before going ahead, I would say, because usually there are two types of application we run on a primary basis if we want to learn about the network activity or the wireless network activity in the local radio periphery. So stumbling is where you actually query the card firmware in order to understand whether there is any network available. It really cannot capture the data. It has a lot of limitation. You cannot even run a lot of injection things over stumblers. In case of scanning, you actually try to run everything in monitor mode and try to capture a lot of data. You can inject data. You have much more control in case you have a scanner running. So this is dumb-based Evil Twin, something you just enable monitor mode, craft a beacon frame with random SSIDs, inject beacon frames, and you just try to prove that, yes, there is some fake network, like the one we have seen in the initial couple of minutes of a presentation. That is the dumb-based Evil Twin. Basically, there is no connectivity in this particular type of Evil Twin as well. This is more of, this kind of access points doesn't actually prove a lot of importance for those who are trying to harvest data from user. So the same demo, you want me to repeat? I won't do that because that would save us some time. So little laser dumb Evil Twin, where you enable monitor mode, sniff the probe requests, respond to the probe responses, now set SSID and broadcast the beacons. No actual connection yet. So here you are trying to personalize a bit, not much. So no data, roll out the fake access point, and yet as there's no connectivity on data, you still won't have a lot of advantage of harvesting information from victim. So the least dumb Evil Twin. So this is something which we normally implement in order to harvest data from user. So here you can see like there is the same set of steps we have followed, having a lot of routing done and things, so that the victim, when we'll connect to this particular access point or a rogue access point, he will get a proper data connectivity, and the administrator who is trying to run this particular Evil Twin will get a lot of data from a victim. I know that's a lot of bullshit, so enough is enough. Let's go to Decepticon. What exactly we're trying to discuss here in the new approach, a little new approach, I would say rather. So the concept of Decepticon, as I have discussed, was started back in BruCON 2015, BruCON 0x07. So what exactly we are trying to come up with is this. Is this visible? If not, I'll read it for you. So for initial or for majority of fake access points which are present so far, what we usually do is like we raise one particular monitor mode, and then we try to communicate over that particular monitor mode for a specific SSID. Fine with that so far? In case of Decepticon, what we have achieved, like we have used only one hardware, and we have set up multiple monitor modes, so as to give a customized, a familiar experience to a victim. So suppose tomorrow victim is sending like 10 probes. Okay, there is Novotel, there is University of Ghent, there is maybe Ghent Centrum. So these 3 probes have been sent by one user. So the user will actually receive a response and connection to one of the network which is nearestly, possibly nearest to this particular location. That is one thing. Other thing, like same time, there is another user who is again sending probe. Now here it comes the limitation of the hardware, or rather the present set of tools. Like we cannot spawn multiple monitor modes in order to run multiple such fake access points on one particular hardware. So here, what we've done is like we have actually removed this particular limitation. Hence, if there is another probe from some another device, then again that probe will be entertained and the another user will receive the same connectivity, which actually may not be present into the local radio periphery otherwise. So again, sniff data link layer frames, set up channels, no beacons, fine. Yes, so this is one again important step we've taken. Just in order to reduce the clutter, we have actually cut down that particular functionality where a particular access point is sending out the beacons. We don't want to advertise it otherwise. We just want to respond to probes. So is the reason we have stopped broadcasting beacons. So yeah, respond to data link layer frames. Yeah, decision maker logic. Here is where we have actually tried to make this whole functionality little more, we can say, intelligent. Not intelligent, we can say, because we are using pretty basic logics as of now. Where like we are trying to add in a lot of geolocation data so that the Decepticon, my access point, will be able to decide, okay, if there are 10 probes by one particular device, out of those 10 probes, there would be one particular probe which is at the nearest geographical location to the present location of that particular victim device. So in that scenario, how to decide this thing? We have that geolocation thing. Other thing we have used is related to some apostrophe logic, where what if that particular probe, which was actually made by a victim device, is not present in our dictionary? How to respond to such things? So there, to give a familiar feeling to that particular victim, we have again put some logic where usually in India they name their SSIDs after somebody's name. So maybe maybe John's network, or maybe McDonald's network, or something like that. So this apostrophe, we have tried to take that particular thing into the SSID, and we've put another kind of little more familiarity to this particular experience. So seamless connectivity, yes, we have set up kind of transparent proxy here so that we can sniff out the data, wherein the user won't be facing a lot of connectivity mess up as well. Yeah, and rollout full-fledged fake access point and collecting devices details. So yes, for here we have actually set up another SQLite server where we are actually collecting a lot of data by majority of the devices which are having their Wi-Fi network interface cards enabled into the local radio periphery. So this is what that seems in altogether will be felt by a victim, and the actual thing is like the latest the bright latest. So your familiar is something that a user will feel, and for those who know what actually is going on, they know like this is liar. So the initial POC, the initial POC we have actually run using Scapy and some Python libraries. That helped, that worked. But then issue with Python and Scapy was like it was a little slow in responding. It had certain issues while interacting with hardware. And it was actually limiting our whole motive to only Decepticon. And had I happened to use certain different attack vectors, then I was supposed to write altogether different set of things which have already been scripted. So to overcome this, we have actually modified Airmon and AirCrackNG, for that matter rather. So I have already explained you like how what exactly we did in case of monitor mode. Like for one particular WLAN 0, for that matter, one particular physical interface, we are actually spawning multiple monitor modes so that it would cater to need of every victim. And yes, full implementation, because using this, we are augmenting AirCrackNG itself. So far, this thing we haven't proposed to AirCrackNG guys, but definitely we will be sharing these things with them. If they feel this thing is worth adding to AirCrackNG suite, they probably will do that. And yes, another utility that we've used from AirCrackNG is that's Airbase NG. We have actually introduced new mode, we call it Decept as of now. And yes, we have added a lot of patches as well. A bit of details that I have actually spoke about. Hidden access point, as we've said, like we have restricted beacons from broadcasting here. Respond to the probes. Legit connection, yes, the transparent proxy will work here properly. Multiple SSIDs on one particular, on one physical interface. That was something which was not present, which was not being allowed by the normal aircrack suite. Information aggregation, yeah, thanks to the database connectivity and all, now we can actually collect a lot of data, and we can run certain learning algorithms on them in order to understand a usage pattern of particular user. And of course, analysis. I just believe the demo would work. Give me a moment. Seems the demo code is not in favor with me, so I probably will run a recording. Yeah. I'm unable to see the demo there. Can you help with this? Extend. Yeah, so here's my, okay, recording as such. Give me a moment. I cannot press. I cannot press. Okay, it's here. Yeah. So the demo we've recorded on the fly, so it may be a little rough and may not be completely visible. My apologies for that. I'll upload the same demo on one of my repositories for those who want to actually refer to this. It will be available. Yeah. I need to run another video from here.
You need to drag it.
It's not coming in here.
Yeah, but you need to go to the left.
Oh.
Then you're here, and then you click it and drag it to the right.
Yeah. So,
or how does this thing work?
Yeah. And here's our demo phone where we have detected the thing. Can we run both the videos parallelly?
Sorry?
Can we run both the videos parallelly?
I don't know if you can put them in.
So the word was the
You need to drag it to the right.
so this was
You need to drag it to the right.
right. Seems good. Yeah. So this was a network which got connected to. Okay. Perfect. I think it should work now. So that was a small demo. I know probably majority of things were not visible here on the screen, but you can use the file. I'll soon share that on one of my repositories. So lessons learned, yep. Host connection allotment, this was really not an easy task. Uh, uh, honestly, hardware behaves a lot different than what exactly has been drafted in the books. It never gives you the things that you want so easily. List of known SSIDs, yes. This list actually we've been populating for a few months, and the set of list is still being populated, and it will be ever populating. Another thing, yes, we are definitely not trying to bring in Weagle here. We are just trying to make everything free. I think Weagle charges something for the set of SSID lists that we try to import from them. SSID generation and list population, yes, we've already spoken about it. Geolocation. So far, the resources that we're using for geolocation here, they're pretty filthy, to be honest. We are yet to derive the proper, or rather more efficient algorithms in order to get this particular geolocation mechanism work properly. Limitations on devices. So while experimenting same thing on Bluetooth, BlackBerry devices, many of the times we did not receive probes from BlackBerry. Honestly, we are yet to study this particular behavior. We could not diagnose this kind of behavior in case of BlackBerry. In case of Apple, the scene was a little different. The Apple used to pop up a warning if the access point that you're connecting to is the same that you're connected in past, but is having a different privacy. So suppose in past I have connected to a network called BruCON. By then I have used a privacy which is like WPA2, and now if I try to connect to the same network that is BruCON, which was probed by my device, but now the privacy is open, then the Apple actually throws a warning back saying in past when you've connected to this particular access point, it was having certain privacy. Now this particular connection is not having any privacy. So this pop-up is actually kind of preventing Decepticon from lying low onto the detection targets. So that still is an issue. We are yet to fix that. So work in progress. So far we've tested this particular Decepticon's capabilities on 5 different devices parallelly. But what if I'm actually trying to run this particular utility in pretty dense populated area? Then yes, how this particular tool will behave, we are yet to test on that. As well, like still this whole Decepticon runs in user land. So embedded OS is something we are yet to work upon. We've not touched that particular part where we can actually introduce any such capability into the kernel mode. So Land is still far away for us. I think this is much of the presentation here. The small acknowledgement. I thank, or rather we all thank our parents, masters and mentors, and of course BruCON 0x08 for giving us an opportunity to showcase our very small set of efforts. I strongly believe this thing is in pretty raw form and needs a lot of inputs, needs a lot of improvements as well. I, I urge you all to suggest us the improvements. I would actually, I would rather take the notes from you in that context and actually want to make this thing a little more elaborate, little more usable for everybody. So all inputs are welcome. However, if you still have any questions, I would be glad to answer them.